Since we've talked about graphing of piecewise functions, we're going to be talking about writing piecewise functions. Now, a lot of this is based on your knowledge of parent functions as well as transformations of functions. How do you shift something left, right, up, down? Okay, so this first one, I made it pretty basic in the fact that we just have lines. So it's a little bit easier. We know that this is going to be 2 lines. Okay, so we're going to have 4 different chunks to finish here. Okay, I don't actually need those parts there. I just wanted to touch base. So I am going to do this one in red and this one in green. So what we're going to do there, easiest part is actually to figure out the interval. So this is going from -4, it's a closed dot, so we'll include it. And it's a closed dot on the right side, and that's to 1. So looking at this, I need to write the equation of that line. Remember, for a line, it's in the form of y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so looking at this, you don't actually write the y equals part, you just do the mx plus b. Looking at my slope here, I am rising 1 and going to the right 1. So I have 1 over 1, and that's okay if you leave it as a fraction, or if you change it to just 1, x. Now I need to figure out my b. Where does it cross the y-axis? That's at this point here, so that's plus 1. Now I'm going to look at the green one. Again, interval to me is always the easiest one. So I'm going from 1, it's an open circle, so we're not including it. Closed circle to 3. If I look at this one, I have a slope of going to the right 1 and down 1. So this is 1 over -1x. In order to find my b-intercept, I might need to extend this line to figure out where that b value is. And I can see there, if I follow my slope and extend it, that it's at 0. So you could put a plus 0 if you really wanted to. You don't have to put a plus 0. It just is up to you. So that right there is our piecewise function. Not too bad. Of course, in typical fish style, we get a little bit more challenging each time we go. So we'll do this one in red. We'll just start there. Again, I'm going to have 3 chunks just because I have 3 separate portions of the graph. I'm going to go ahead and start with my interval because, again, it's the easiest. I have an arrow, and we know that an arrow represents infinity, whether it's positive or negative. You can list it if you really want to. Might help just to keep yourself in the mindset that you're going to have a left bound and a right bound. Your left bound just happens to be negative infinity. And then we're going to 1. Okay, so I need to think back on my parent functions. What has that shape? And that would be an x squared. Now, here's the tricky part. This is going back to our transformations. The bottom of the parabola is going to be what's going to move our x squared. If it is moved left, right, etc. Well, considering that our parabola happens to be at 0, 0, it isn't actually moved. So this is just x squared. Now, say for instance, you think it shifted to the right, so you're going to go x minus 1 squared. If you're not confident with what that actually looks like as a graph, go to Desmos. Desmos will help you determine, and then you can compare and contrast whether those are actually the same. Do that green portion. The green portion is a constant number at 3. So we just listed at 3. This is going from 1 to 2. Again, notice my intervals there, what's included, what's not included. And then my last portion here, I'm going from 2 to infinity. Again, you don't have to list the infinity part. It might help you though, because you always have a left and a right bound. So I need to write the equation of this line. I can see here, I'm rising 1 and going to the right 1, so I have a slope of 1. If I were to extend this, I can see that my y-intercept would be 0, so I'm just going to leave it as 1x. I'm not going to add in that plus 0. And I have one more for you. This one, we have 2 different portions. By the way, you should draw a rough sketch of all of these graphs, because if you don't and you try to go back to your notes, it's not going to make sense if you just have the equations written down. Just a FYI, heads up. Anyway, last one. So I have an equation of a line here, and we're going from negative infinity to 5. I'm going to start here with my y-intercept. My y-intercept is at negative 4. And then I'm going to find my slope. Okay, so looking at this, I went down 3 and right 2. So it's negative 3 over 2, x minus 4. Now let's look at this last one. This last one, I have to go back and think about my parent functions. Looking at those parent functions, this is a square root function. Now, here is what I was talking about before with the Desmos part. So on a regular square root, this is at 0, 0. But if I look at this portion here, that's not at 0, 0. That's shifted down. Okay, so vertical transformations, remember, are after your function. So I have a square root of x, and then it's going to be plus or minus your vertical shift. So because we're shifting down, I'm going to have the square root of x, I close off that square root, minus 1. And I can see here, oh goodness, you guys shouldn't follow me sometimes. That's not 5 there. Sorry, I was looking at I don't know what I was looking at. Probably this negative 5. But that goes to 0. My bad. Anyway, so this interval for the green is from 0 to infinity. I'm sorry about that. I should have caught that earlier. But again, say for instance you're not confident with this vertical shift here, or maybe it's a horizontal shift, always check it on Desmos. That way you're confident overall and you will have a better idea of what your graph actually looks like.